The goal of this demo is to preview some of the new graphical techniques made possible using the new features of DirectX 10.1 and the Spider platform. In particular, it shows off a new lighting technique known as real-time global illumination, together with a scalable physics simulation optimized for multi-core systems. To make it a little more interesting and interactive, we decided to include some simple gameplay elements as well. What you're currently seeing is thousands of distinct ping-pong balls, all being physically simulated on a quad-core Phenom CPU and rendered on a Radeon HD 3800 series GPU. You can see that every ball is being lit simultaneously by multiple area light sources, casting soft shadows on each other and the environment. Some of the more subtle effects include indirect lighting, multi-sample anti-aliasing, or MSAA, environmental reflections, and even a GPU fluid simulation for the plasma screen dividing the two halves of the room. And obviously, the frame rates are very smooth. One of the things that still differentiates offline CG rendering from real-time 3D rendering today is indirect lighting. Today's games almost exclusively use light and shadow maps for lighting, which work by rendering the scene from the point of view of each light source. The problem is that in the real world, light is bouncing around everywhere, so having just a few discrete light sources cannot accurately simulate real lighting. You can see what happens to the scene when indirect lighting isn't taken into account. In this case, we use constant ambient lighting instead, which is the approximation most games use today. You can see that the multicolored light sources no longer bounce their light throughout the room, so it looks much less realistic, and the location of the balls becomes more difficult to determine. When I turn off the ambient occlusion shadows, you can see how important the soft shadows are to this type of scene. Using shadow maps for a scene like this with many dynamic objects isn't really practical. Either they would have to have hard, aliased edges, or frame rates would drop too low. With DirectX 10.1, we can use this superior technique for fast, high-quality soft shadows that work with any number of objects. This mode helps us to visualize how the global illumination is being computed. The scene is divided into a grid of cubes, each with a light probe at its center. For each light probe, the light falling on it from all directions is captured in cube maps, then compressed with spherical harmonics. Cube map arrays and geometry shaders let us update many of these probes in a single pass each frame. Note that this is a highly scalable method since we can easily increase the number of cubes to take advantage of additional stream processors, or decrease the number on lower-end GPUs. You can see that another advantage of using these cube maps is that every single ball can reflect the entire scene. The quality of these reflections is easily scalable as well, according to the processing power available and the desired performance level. We also talked about how DirectX 10.1 can improve anti-aliasing. One of the limitations of anti-aliasing today is its poor compatibility with deferred shading techniques, such as those used in new Unreal Engine games. Deferred shading is also used in this demo. It works by doing a pre-pass of the scene to determine which pixels are in the foreground, then a second pass to shade only those pixels. This gains a lot of performance in a scene like you see here, where you have thousands of overlapping balls. However, standard multi-sample anti-aliasing works on polygon edges only, and the locations of these edges are lost after the pre-pass is completed. In the ping pong game, we use the new features of DirectX 10.1 to implement a custom edge detect filter. The pixels highlighted in red represent edge pixels detected by this filter. Edge pixels are identified by searching for discontinuities in the multi-sample depth buffer. Anti-aliasing is performed on these pixels only, resulting in maximum efficiency. The ping pong balls are drawn as billboards with a procedural shader that exports a sample mask at the procedural boundaries, ensuring that anti-aliasing will be performed correctly for the balls. As you can see, the new features of DirectX 10.1 make AMD's Spider platform the smarter choice for the ultimate visual experience.